Hello everyone, we are going to do some chemistry lessons today. At physical classes, we already studied up to chapter 5. So today we have to start with the chapter 6, chemical energetics. Okay, that's the 6th chapter. And for those who don't know about me, I am Dr. Vatsala S. Jayasinghe, working in the health field, but also I have been working as a teacher, specialist science teacher for more than 12 years. So in this class, we will do chemistry, physics, biology lessons. As the chemistry, we refer this book, Cambridge O-Level Chemistry book. That's the book that we refer. And there we have to do the chemical energetics chapter, chapter 6. That's the chapter we have to study today. So before learning this chapter, you should have an idea about what is an energy. Already you have studied in the previous classes what is an energy and the sources of energy and some types of energy, etc. These ideas should be in your mind. So we are not going to discuss these things, energy, sources of energy, the types of energy. What we are going to mainly discuss about the fossil fuels and the petroleum substances and some calculations based on that. That will be with this chapter. So when we talk about, before learning about these things, let's have a revision, quick revision about what is a fossil fuel. Okay, what is a fossil fuel? Already we have an idea, we have discussed about the main 3 examples for fossil fuels. They are 3 examples for fossil fuels. They are, one is the coal, the other one is petroleum, the other one is natural gas. Okay, these are the main 3 examples for fossil fuels. And when we learn about the fossil fuels, we have already discussed about the formation of fossil fuel. How they are formed. These fossil fuels are formed from the dead plants and animals, dead animals and some bacteria, and they went through a process of fossilization. This has happened more than 200 million years ago. So this has happened more than 200 million years ago. And also we know that this is a non-renewable energy. That is a non-renewable energy. What does it mean? That means we use it and it doesn't again happen as the rate we consume it. So this is a main fault. So that those things are non-renewable energy. And one example for renewable energy is solar. Okay, those things are renewable energy. Solar, tidal waves, wind are some examples for renewable energy. And based on that, you have another chapter. In that chapter, we will be discussing in detail about those things. So first of all, write down the main chapter, chapter 6, chemical energetics. Under that, write down the first subtopic, fossil fuel. Okay, under that, you can write with some red star marks or star marks. First one is fossil fuels. Some examples for fossil fuels are coal, petroleum and natural gas. Write down the next point. These fossil fuels are formed from the dead plants and animals through the process of fossilization happened 200 million years ago. And fossil fuel is a next star mark. Fossil fuel is a non-renewable energy. So regarding fossil fuel, mainly here we will discuss about the petroleum products. Okay, here we will mainly discuss about the petroleum products or the petroleum substances. So what do you already we are happening there can be even a war happen because of these petroleum products, and even now we have that experience also. So when we talk about petroleum products, first of all, it is a type of fuel. Okay, it is a type of fuel and it is a mixture of hydrocarbon. It is a mixture of hydrocarbon. What does it mean as hydrocarbon? Already in the periodic table chapter, we discussed about the symbols. Periodic table, they are symbols of the elements. Hydro means hydrogen, carbon means carbon. So if any substance, if any compound contains carbon and hydrogen, simply I am telling, if any compounds contain carbon and hydrogen, that can be called as a hydrocarbon. So petroleum is a mixture of hydrocarbon. That one you have to keep in mind. And also when you learn about petroleum, by burning them we can get energy. That is the next point. By burning them we can get energy. And the other thing is petroleum is also known as crude oil. Crude oil. It should go through a process. Then only we can use it. The process is known as refining oil. Okay, refining oil. Then only we can use this petroleum as a fuel. Some examples for petroleum products are petrol, diesel, kerosene oil, etc. Now you understand the value of petroleum products. Write down next subtopic, petroleum substances. Petroleum substances. Under that, write down the first point, petroleum is a fuel. Petroleum is a fuel. Next point, the mixture of hydrocarbon. That means it contains carbon and hydrogen. Write within brackets. That means it contains carbon and hydrogen. Next point, petroleum is also known as crude oil. Petroleum must be gone through a refining process, then only we can use it as a fuel. Some examples for petroleum substances are petrol, diesel and kerosene oil. Okay, now let's learn about the oil refining process. I told that crude oil is there or the petroleum is there, we can't use as it is, we have to go through a process. It's like that. Now we have rice here which is uncooked. So since it is uncooked, we can't eat it, we have to cook it. So cooking is the process. Once cooked, we can eat the rice. So as it is, as a raw material, it is useless, but once when it goes through a process, then only it's very worthy. In here, crude oil is used. Crude oil is heated. At different temperatures, we can get different type of petroleum substances. For that, we have to use a fractional tower. This process is happening inside the fractional tower. Okay, this is happening in a fractional tower. And also this process is known as fractional distillation. This process is known as fractional distillation. Regarding fractional distillation, as I can remember, you have a chapter 14. There you will learn about the production of ethanol and the separation. There you will learn about more. And also in these videos, I am going to give you a summary in the PDF forms, and more further clarifications will be done at the physical class. So here you can see even in the page number 85, there's a nice picture of a fractional tower. In there it has mentioned how it is separating in different temperatures. These can be asked as MCQs. So at the first of all at the 30 Celsius degrees gasoline, the petrol is there, which is used for the cars. At the temperature 110, methane is produced, and at the temperature of 180, kerosene is produced. It is used for jets and all. And at the temperature 260, diesel or the diesel oil is produced. Likewise, for with different temperature, these different types of petroleum substances are produced. Anyhow, you have to memorize these. Petroleum substances should go through a refining process, and that process is based on the fractional distillation. This process is happening inside a fractional tower. So write down next subtopic, oil refining. Under that, write down separation of petroleum substances into different fraction is known as oil refining. The method is fractional distillation. It is happened inside a fractional tower. So if you want to have a rough idea, so you can note down this also, what is happening at the temperature 30, 110, 180, 260, etc. So crude oil is there, it is heated. That is the process of oil refining. Now let's learn about fuel. So imagine, now we know some examples for fuels, now petrol, diesel, those things. So why we use petrol and diesel as fuels? Why can't we use water? Even the water, when the steam comes, there is some energy, but why can't we use them? Why we rely on these petrol, diesel things? The thing is, especially the petroleum based products, the thing is they are known as perfect fuel. So perfect fuel means that should be cheap. The first one is it should be cheap and it should be easily available. It should be easily available. If it is not available, even though it is cheap, we can't buy them, and it should be easily available, and the refining process must be not much complex. It should be not much complex. Anyhow, it's complex, but it should not be much complex, as well as it should be there for a period of time. I mean, if we started the invention of the engine in 18th or 19th century, it should be there for more than at least 2-3 centuries. Likewise, it should be there, or else it is not good. So in your textbook they have mentioned the characteristics of perfect fuel. Write down the characteristics of perfect fuel. First one is being cheap. Second one, being available in large quantities. Third one, that I forgot to explain, be safe to store and transport. Next one, be capable of releasing large amounts of energy. Be easy to ignite and burn, causing less amount of pollution. Next point, release no greenhouse gases. These things are there in your page number 87 in your textbook. So these are the perfect fuel. So sometimes they can ask, write some characteristics of the perfect fuel, or even in MCQ they can give which one is not, like that. So you have to study like that. Then as I earlier also I told, we have to move for alternative sources of energy. Why? This fuel is or the fossil fuel or the petroleum substances, all these are known as what? Non-renewable energy. So one day they will be over. Once when we consume more, we have to gain it more. So but one day it will be over. So for that we have to find an alternative solution. So now the trend is moving to find alternative solution for this fossil fuel. So they are mainly focusing on renewable energy. Write down next topic, alternative sources to fossil fuels. Right under that, fossil fuel is a non-renewable energy. Fossil fuel is a non-renewable energy source. That means, write with a red star mark, since this is a definition. They are not being replaced at the same rate as they are being used. Right, next point. So people try to find alternative sources, right, within brackets, renewable energy, like nuclear, solar energy, geothermal energy, wind, etc. That's the thing. So then after you have to learn about exothermic reactions and endothermic reactions. Exothermic reactions and endothermic reactions. Already you have an idea what does this exo and what does this endo means. Okay, because we have studied the cell, we studied about the fluids, there also the words have come, exo and endo. Exo means if it gives something out, like exit, out. Endo means if it takes to inside. Okay, those are the meanings. Okay, and even when we study about the uterus, can you remember perimetrium, myometrium, endometrium? Endometrium was the innermost layer. Likewise, endo means if it is inside, the word is endo. If it is outside, the word is exo. So the thermic idea will give you, thermic means heat. If it releases heat outside, that is a exothermic reaction. if it takes the energy inside, that means the outside will become cool, that is known as a endothermic reaction. Clear? Those are the simple definitions. Write down exothermic and endothermic reactions. That's the next subtopic. Right under that, combustion is an exothermic reaction. Is an exothermic reaction. Is an exothermic reaction. Now, before learning that, okay, before learning the calculation part, you should have some idea about these petroleum products, how their structure of the structure of the petroleum products or the fossil fuel. So I already told important point, petroleum substance is a mixture of hydrocarbon. So hydrogen means H, carbon means C there. And we studied about the covalent bonds. There we studied methane. Methane is CH4. So now you can understand the simplest hydrocarbon is methane. Simplest hydrocarbon is methane. So when this is burnt, combustion means burning with oxygen. Combustion means burning with oxygen. When methane burn with oxygen, they will produce what? Carbon dioxide and water, and they release a huge amount of energy, plus energy will be released. So we have to balance the formula. This is the formula. So if it produces carbon dioxide and water, this is known as what? Complete combustion. Complete. That means methane is completely burned. Okay, so this is known as a complete combustion. Sometimes this is happening in incomplete way, incomplete manner. That is, they produce not carbon dioxide, they produce carbon monoxide. So already we discussed about combustion. You have to keep in mind these things. Combustion happens in two ways: complete combustion and incomplete combustion. Complete combustion means it will be mixed with oxygen completely and carbon dioxide will be produced and a huge amount of energy will be released. In incomplete combustion, I have taken as the example methane, the smallest hydrocarbon. When it is mixed with oxygen or burned with oxygen, carbon monoxide will be produced. Mono means one. Okay, di means two, mono means one. So here only carbon monoxide will be produced, and we know that carbon monoxide is toxic. So in older time, in previous vehicles, that means before 1960s, 50 like vehicles, they produced carbon monoxide. It was toxic to the surrounding. Anyway, keep in mind that these anyhow they will release energy, and also these are exothermic reactions. Exothermic reaction means they release heat to the surrounding. That's why when more vehicles runs on the roads, the more heat will be there, because they release heat to the surrounding. These things should be in your mind. And also we told that methane is taken here. So when these bonds are breaking down, when new things are formed, energy will be released now. So regarding that, you have to do calculations. Here there are 4 covalent bonds. So when these bonds are broken, energy will be released. Regarding that, you have to do calculations. These calculations part will be specially discussed in the physical class. So this is just a summary of that theory lessons. Regarding that, we will discuss in detail in the classes. Thank you all.